The term fractal was coined by mathematician Benoit Mandelbrot in 1975. The word refers to a special kind of repeating mathematical pattern. If you zoom in on a fractal, you'll see the exact same pattern repeating itself, no matter how close you look. This is called self-similarity, referring to the fact that the small parts of a fractal resemble the entire shape. So let's take a look at where this incredible pattern pops up in nature. You've most definitely come across trees, rivers, and lightning, whether in real life or in a photograph, but I bet you've never noticed that all of these things share a common fractal structure. Let's begin by looking at the way a tree grows. Their trunks split off into multiple large branches, which then split off again into smaller twigs. This is the exact kind of self-similarity that we were talking about earlier. The shape of one branch looks almost exactly the same as the entire tree. Rivers and lightning bolts follow the same idea. As water flows down the main river, it deepens the channel and begins to form new, smaller ones through erosion. Similarly, the main lightning bolt offshoots into smaller and smaller sections that show the same jagged structure as the entire bolt. While it's interesting to see the overlaps between mathematics and the natural world, you may be wondering what exactly makes these fractal patterns so common, or why they're so important. The answer to these questions boils down to one thing. Fractal patterns are exceptionally efficient. The fractal branching of trees allows them to efficiently transport water and nutrients. A river's fractal design efficiently collects and transports water to a single outlet like a sea or lake. And fractal patterns are the most efficient way for lightning bolts to spread energy and make contact with the ground. In other words, these simple, repeatable patterns allow both organisms and natural phenomena to do more with less. Although, it's important to recognize that neither evolution nor the forces of nature understand mathematics. Natural selection simply favors patterns that work, and the efficiency of fractals has given organisms with these structures a competitive advantage over others. Just like evolution, natural, non-living structures like rivers and lightning exhibit these fractal shapes because they solve physical problems like flowing, spreading, and branching with maximum efficiency. Fractals are much more than just abstract patterns. Whether shaped by natural selection or physical forces, fractals reveal that math is deeply woven into the fabric of our natural world.